Hi, my name is Wang Yuting and I'm from Section 3. I'm from the Team Fortune. So today I'll explain my individual contribution to the autonomous driving project. So my role in the team was mainly focused on the computer vision and safety logic. So I worked on improving the token detection, adding the debug visualization, and implementing the camera trailing car avoidance. So the first commit is restrict the token detection to a road RI. So the problem was the car could detect the token colors outside a road, such as a glass, a road shoulder, or background object. So this could cause a false staring decision. So to solve this, I add a road RI mask. I create a polygon that matched the visual road area in the 300 to 20 by 240 front camera frame. Then apply it to the green, red, and yellow mask using the CV2.bitewise algorithm. So I choose this method because it's simple, fast, and suitable for real-time driving. A more complex method like the route segmentation would be slower, but the route shade in the camera view is predictable. So the outcome is the token detection only happen inside route, so false positive are reduced. The second commit is add the debug overlay for the token colors and file lane detection. So the problem was it's hard to verify the detection only using the print statement. So I need to visualize the check which lane each token was detected in. So I add 5 perspective over lens using the helper function like the root H and Y pixel X to debug the lane and debug lane divided X. This function would follow the trapezoid shape of the root instead of splitting the screen into the equal columns. So I choose this method because the root perspective make the equal white lens inaccurate. So the overlay now shows the lane dividers, token bonding box, and levels. So the outcome is easier to debugging and better proof that the system is answer the token position correctly. The third commit is add the trailing car crash avoidance logic. So this is a main safety feature. The problem was the car mostly react to the front camera, but it also need to avoid a chasing car from behind. So for detection, I use the back camera RI. So the code convert the frame to grayscale, calculate the brightness and construct, apply the blue using the carrying edge detection and find the largest edge block. So the main function is evaluate the trailing signal. So it check different dangerous cases such as normal, the huge approach, dim close, weak close, very dark and approach. So this use edge density contracts the block size and block position. So I choose this method instead of the color detection because the trailing car can appear bright, dark, or partially visible. So the edge and shape feature are more reliable than the color alone. After detection, choose the trailing escape direction, decided where to escape left or right. So then the code set the tap steering, tap timer, trailing, escape, send timer, and cool down the values to send a control steering action. So the outcome is the car can now detect the danger from behind and perform an emergency lane escape. So overall, my 3 commit improve accuracy, debugging the visibility, and safety. So they show my individual work in the RI masking, perspective lane mapping, contour the analysis, real camera detection, and real-time steering control. That's all. Thank you.